Hello, sixth graders. This is the second part of lesson 7.4, writing equations in two variables. The first half of lesson 7.4 talked about solutions to equations in two variables and which variable was the dependent and which was the independent variable. That's what we talked about in our last video. In this video, we're going to talk about how to graph equations in two variables. So looking at the screen, the key idea says tables, graphs, and equations. You can use tables and graphs to represent equations in two variables. The table and the graph below represent the equation y equals x plus 2. So what they've done is they have chosen some values for x. And they chose 1, 2, and 3 for x. When they substituted 1, 2, and 3 for x, and then added 2, then we found our y value. So if x was 1 and we added 2, y became 3. If x was 2 and we added 2, y equaled 4. When x was 3 and we added 2, y equaled 5. So we made an ordered pair out of our x and y, 1, 3, 2, 4, and 3, 5. Then we plotted those ordered pairs, 1, 3, 2, 4, and 3, 5. So this is how you can use a table to then make a graph of an equation. So the types of problems that you're going to see on your homework today are similar to this one. It says an athlete burns 200 calories weightlifting. The athlete then works out on an elliptical trainer and burns 10 calories for every minute. Write and graph an equation in two variables that represents the total number of calories burned during the workout. So I want to direct your attention to the directions. The directions say write and graph an equation in two variables that represents the total number of calories burned during the workout. So we are going to start with writing our equation. Our equation needs to represent the total number of calories burned during the workout. I am going to use the variable C to represent the total number of calories burned during the workout. So the total number of calories burned is going to equal the 200 calories that were burned during weightlifting, plus it says that the athlete burns 10 calories for every minute on the elliptical. So 10 calories for every minute would mean 10 calories multiplied by the number of minutes. So my equation for this problem is C equals 200 plus 10 times m. Again, this is the number of calories burned after burning 200 calories while weightlifting plus 10 calories for every minute on the elliptical. So I've written my equation, and now I'm going to graph my equation. Here's the thing though, you guys. On these problems that say write and graph an equation in two variables, you're actually going to do three things. You're going to write your equation like we did. Then you're going to make a table like I showed you on the previous example. And once you have the table done, you'll take the information from the table and graph it. So your directions have two parts, write and graph an equation, but you're really going to do three things because you're going to write your equation, you're going to make your table, and then you're going to make a graph. So my equation was C equals 200 plus m. I'm going to make a table that includes the values I'm going to choose for m, and then I'm going to put my equation in my table. And once I've chosen my values for m and I've substituted them into my equation, then I'll know what C equals. And I will then make an ordered pair out of MC. And once I have my ordered pair for MC, that is what I will graph. So as a general rule, I usually pick about 3 values for M. So I'm thinking, okay, M stands for the number of minutes that I've worked out on the elliptical. What would be some reasonable amounts that you could work out on an elliptical? You're not going to choose something unreasonable like 200, okay? Because we don't want to be on the elliptical for 200 minutes. That's over 2 hours. That's over 3 hours. That's a long time. So I'm thinking a reasonable value might be maybe 10. Maybe I'm going to be on the elliptical for 10 minutes. Or maybe 20 minutes. Or maybe 30 minutes. So there's not necessarily a right or wrong for how much, what you choose for M. You just want to choose something reasonable. I don't think 1 is very reasonable. You're probably not going to get on and just be on for 1 minute and then hop off. You'll probably spend a little time. Okay? So I'm going to substitute 10, 20, and 30 into my equation. So I'll do my first line. C equals 200 plus 10 times 10. Because remember, I've chosen 10 for M in this line. So I multiply first. 10 times 10 is 100. Plus 200 would be 300. This tells me if I spend 10 minutes on the elliptical after lifting weights, I would have burned a total of 300 calories. So my ordered pair is MC, which is 10, 300. Now I'll do the next line. So I'm going to substitute 20. So I'll have C equals 200 plus 10 times 20. Well, 10 times 20 is 200, plus 200 more would be 400. So if I'm on the elliptical for 20 minutes after weightlifting, I will have burned 400 calories. So my ordered pair is 20, 400. And last but not least, I'll do 30. So C equals 200 plus 10 times 30. 10 times 30 is 300, plus 200 would be 500, and my ordered pair would be 30, 500. So I've written my equation, I've made my table, now I'm ready to graph. I am going to take the ordered pairs from this last column, and that's what I'm going to graph. Once I have graphed those values on my coordinate plane, I will have a line. It's going to look something like this. So my x-axis is my M, or my minutes. My y-axis was my C, which was my calories. And I graphed 10, 300, 20, 400, and 30, 500. So I wrote an equation. I made a table so that I would have ordered pairs, and then I graphed those ordered pairs. These are the types of questions that you will see on your homework today. So there are several steps. If you need to watch this video more than once in order to complete all those steps, you certainly may. On your homework for today, we have problem number 24, which we're going to do together. So this next problem that we're going to do together is number 24 on your homework. So tune in. So problem 24 says texting. The maximum size of a text message is 160 characters. A space counts as 1 character. Also, a period would count as 1 character. So for A, we're going to write an equation in 2 variables that represents the remaining or the unused characters in your text message as you type. B, we're going to identify the independent and dependent variables. And then C, we're going to figure out how many characters remain in the message shown. We'll figure that out by solving that equation that we wrote in A. So looking at this screen on this phone, I'm first going to count the number of characters that are used. I'm seeing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 characters are used. I counted the spaces and the period. I got 15. And I know that the total is 160 characters. The equation needs to represent the remaining or unused characters in your text message as you type. So I want to figure out how many characters remain. I'm going to use R to represent the number of characters that remain. And I'm going to say R, or the remaining number of characters, equals 160 minus the number of characters that I've used. I'm going to use U to stand for used. Notice I'm not going to use 15 yet because the first direction says write an equation in two variables. So instead of using 15, I'm going to use a variable U to represent how many characters I've used, because the directions say an equation in two variables. So I need two variables, R and U. B says to identify the independent and dependent variables. On this one, I'm not going to tell you the answer. I'm going to have you figure it out, but I am going to give you something to think about. Think about how the independent variable would be the variable that changes freely. It can change from message to message. The dependent variable is the one that depends on the other. So thinking about R, or the remaining characters, and U, the used characters, which one of those is going to depend on the other one? That's what I want you to think about, and I'm going to have you answer part B on your own. Part C says how many characters remain in the message shown. So this is where we're going to use 15. Our equation, R equals 160 minus U. Now we're going to substitute 15 for U. R equals 160 minus 15. That's going to tell us how many characters remain in this message. Obviously, you can solve that on your own without my help. Okay, kiddos? So there's some hints to help get you started on number 24, because this one was a little bit tricky. You will also have some problems on your homework that need you to use the distance formula. The distance formula is D equals RT. And D is the distance traveled. R is the speed, and T is the time. So you can substitute anything that you know. If you know the distance, you can put that in for D. If you know the speed, you can substitute that for R. If you know the time, you can substitute that for T. So D equals RT is the distance formula that you'll use on your homework. This example says a train averages 40 miles per hour between two cities. Use a graph to show the relationship between the time and the distance traveled. Remember that we're using the distance formula. D equals RT. One thing you could do is you could make a ratio table. So your ratio table could be used, and multiplication could be used to find equivalent rates. So it said 40 miles per hour. That means 40 miles in 1 hour. If you multiply 1 times 2 and 40 times 2, then you know that your train would also travel 80 miles in 2 hours. Or if you multiplied 1 and 40 times 4, then you would know that your train could travel 160 miles in 4 hours, and so on. Then you can just make ordered pairs out of the values in your ratio table. So an ordered pair could be 1, 40, or 2, 80, or 4, 160, and you could graph those values as shown in the picture. Another option to solve that problem would be to make an equation, or to write an equation in two variables and then make a table based on that. So you can use the distance formula, which you recall is d equals RT, and D stands for distance. In this problem, it did not tell us anything about the distance traveled. It just told us the speed was 40 miles per hour. So since we don't know D, we will leave D alone. We'll just leave it as D for our equation. R is the speed, which we do know. We know the speed is 40 miles per hour. So we're going to substitute 40 for R, and then T is time, which we don't know yet, but we're going to choose some values for time. So our distance formula, D equals RT, helped us write the equation D equals 40T. We're going to use that equation that we wrote, D equals 40T, and put it in the table. So notice, guys, in our table, it's kind of like the one that we did together just a couple problems ago. We have our values for T that we're going to choose. We have our formula. Once we substitute our values for T, then we will know D, and we'll make an ordered pair out of T and D. So again, we're choosing some values for T, and we're just choosing some reasonable values. T is the time in hours. Again, we don't want to choose 100. It's not going to take us 100 hours to ride in a train somewhere. But it could take 1, 2, 3, 4, 5, 6. Those would be reasonable times to be traveling. So the textbook chose 1, 2, 4, and 6. And then they took those T values and substituted them into the equation. So then they had D equals 40 times 1, which told us D was 40. And they made the ordered pair 140. Then when they chose 2 for T, they substituted 2 into the equation. 2 times 40 is 80. So if our time is 2 hours, our distance is 80 miles, and that gives us the ordered pair 280. If we use 4 for T, 4 times 40 was 160. So after 4 hours, we would have traveled 160 miles. That helps us write the ordered pair 4, 160. And then if we choose 6 hours of train time, 6 times 40 is 240, and our ordered pair is 6, 240. Now we can graph these values, and that graph would look like this.